Hey y'all, have you ever been investigating a query that is performing poorly? If so, you are likely familiar with the concept of explaining the query to see how the database is choosing to obtain the results. Explain can help you understand whether the query is doing a full table scan or a slightly more optimal index scan, but it doesn't really tell you why the database is choosing this method. And a data guardian will need to understand that why. So today, let's take a look under the hood at the MySQL optimizer. A typical application will make many calls to the database to gather information for the end user. These requests are called queries. It is unlikely that you will want to make your users wait for more than a few milliseconds to gather this information. So, query performance is super critical for any serious application. A database like MySQL will likely have multiple ways to retrieve the results of a query. Simple queries can either be a full table scan or can utilize an index. There are different types of scans that can be utilized depending on the filters of the where clause. And the number of ways to get the results of the query can get even more complicated if subqueries and joins are involved. To keep query performance fast, MySQL has to make a quick decision of which path to take. And this is what the optimizer does. In simple terms, it estimates a cost for each potential path to get the results of the query based on how the query is constructed. If you are interested, the MySQL documentation has the different primary optimizations as well as other optimizations. It's a bit of light reading that requires at least 2 cups of coffee. But okay, great. The optimizer determines the cost of retrieving results. So what? Well, if you've ever tried investigating query performance, I assume you have looked at the explain output. This has told you how MySQL has resolved the query. But have you ever looked at a query that suddenly started performing poorly and been left wondering why? Sometimes it is because the optimizer chose a different path. It's also common that the path can change based off the values of the query, because the values change the selectivity of the results. Imagine if you have a table that tracks all of your user activity. It's early stage of your application, so you have one user that contains 90% of your activity. When selecting for that user, MySQL could decide that it costs less to do a full table scan than using that nice user ID index that you have on the table. Unfortunately, explain won't give you the why, only the how. Luckily, you have the ability to trace the optimizer to find out why. To trace the MySQL optimizer, you have to turn it on for your session. This is achieved by setting optimizer trace equals enabled on. Be warned though, the output can be long. Then you run the query you want to trace. You can retrieve the results from the information schema optimizer trace table. Tracing a query is session specific. So once you have run your query and retrieved the results, you can turn the trace off. This helps avoid trace penalties while you continue investigating your query. As I mentioned, the output is very long. It contains information for each path that the optimizer can choose to retrieve results. What you are typically looking for is the cost associated with each option. In the optimizer, the lower cost wins. Query performance is critical to your application performance. It is the job of the MySQL optimizer to quickly choose the best strategy to retrieve results for the queries. As a data guardian, you will need to be able to dig into why the MySQL optimizer chose a particular path. Luckily, MySQL provides you a way to trace the optimizer so that you can find out why. Now that you know how to trace the MySQL optimizer, I wish you happy performance tuning.